Bismillahirrahmanirrahim. Assalamualaikum everyone. Today our topic is 2.11 increasing and decreasing functions. Okay, for your information, our topic today is part of application of derivatives. Okay, first example from the graph. Okay, how can we find the increasing and decreasing interval from the graph? We read the graph from the left to right. Okay, from left to right. Meaning that from 1 to 4, 4 to 5, 5 to 7. Okay, it depends on the pattern of your graph. And then there is no inclusive and exclusive interval. You can write either by using open bracket or square bracket. Okay. Okay, now what is your increasing interval from the graph? Increasing means you can see the graph increase. Okay, from the lowest point to the highest. Okay, this is the increasing interval. The interval is negative infinity to 1, negative infinity to 1. And then 4 to 5, okay, 4 to 5 increase. We stop here because of this is undefined coordinate. And then 5 to 7, we stop 7 because of 7 is asymptote. Okay, now our decreasing interval start from 1 to 4, 1 to 4, decreasing. And then we have here this one, okay, decreasing from 7 to 8. We stop 8 because of our slope is 0. Okay, there is no increasing or decreasing pattern here. Slope is 0, no slope. And then 8 to infinity. Okay, because of why 8 to infinity? Because the graph goes to right. Okay, 8 to infinity. Okay, this is the increasing, decreasing function. Okay, in this topic, in this video, I also include topic 2.11. Okay, where you have to find the relative maximum and relative minimum. How can we find the relative maximum and minimum? Because of, okay, actually for the relative maximum, this is you have to give in terms of points. Alright, in terms of points. Here, relative maximum. Okay, we have two different graphs here. Highest point. Relative minimum is the lowest point. Okay, the coordinate of the lowest point. Okay, in graph, okay, what is our relative maximum? Our relative maximum is at here. When x equal to 1. When x equal to 1 is our relative maximum. And relative minimum when x equal to 4, the lowest. Okay, when x equal to 4. Okay, I hope you understand for the example. Now we proceed next examples. Okay, from the function given, not from the graph given. Just now from the graph you find the intervals. Now from the function given, how can we find the increasing, decreasing function? Okay, our function right now is, okay, given fx equal to x plus 1 over x. Okay, find A, the interval where the function is increasing, decrease. B, okay, what is relative extrema? Means that you have to find the maximum and minimum. Okay, how can we find? We have to use the first order derivatives. Okay, if we use second order derivatives, meaning that we find the concave upward and downward. This is topic for 2.14 if I'm not mistaken. Alright. Okay, here we have some steps. You have to remember the steps. First step, you have to find the domain. Okay, you have to find the domain of the function. Okay, for this function, x plus 1 over x. What is our domain? Okay, our domain is all r. Okay, why all r? Because of x. We can put all real numbers. And then 1 over x. Okay, all r except x equal to 0. Okay. Okay, so this is the domain. All r except x equal to 0. What does it mean by x equal to 0? Means that the graph has asymptote at x equal to 0. When x equal to 0. Okay, step 2, you have to draw number line. Number line meaning that from negative infinity to infinity. Okay, so 0, our asymptote. We have asymptote here. Step number 3, find f prime x. Differentiate first order from the function. Okay, our function x plus 1 over x. 1 over x change into the pattern x power of negative 1. Okay, differentiate this one, you get 1. Okay, differentiate x, you get 1. And then differentiate 1 over x. Okay, remember we have negative 1, we bring in front. And then x power, we minus 1, we have negative 2. So, we change the pattern again. Okay, for the original pattern, we have here 1 minus 1 over x square. Okay, we change this one into quotient form, meaning that we have fraction. We make, okay, same the denominator, we have to make the denominator for these two, x square. Okay, so 1 multiplied by x square, we get here x square minus 1 over x square. Okay, this is numerator, then this is denominator. Okay, remember 3 steps. Step 1, find the domain. Step 2, draw number line. Step 3, differentiate first order. Okay, now step 4. Okay, this is very important. Where step 4, you have to find the critical points where there is a turning point. Okay, where the function might be it goes to increase or decrease. Okay, so to find the critical points, we set f prime x equal to 0. Okay, when f prime x equal to 0, you have to take the numerator part. Make it, okay, x numerator equal to 0. Our numerator just now is x square minus 1. So when x square minus 1 equal to 0, we have here, okay, x square minus 1, meaning that, okay, change into this pattern, x minus 1, x plus 1. So we have here x minus 1 equal to 0, x equal to 1, where this part x plus 1 equal to 0 when, okay, our answer is x equal to negative 1. Okay, meaning that our critical point we have, from the numerator, we have 2 critical points. How about the denominator? Okay, for the denominator, we set f prime x undefined. Okay, denominator is equal to 0, where the denominator equal to 0. Okay, our denominator just now is x square. When x square equal to 0, x equal to 0. So here we have 3 critical points or critical values. Now step number 5, you bring your answers in step 4 to the number line. Just now we already draw the number line. Okay, we have our asymptote x equal to 0, right? Now we add, okay, we have here negative 1. And then we have here 0, already we have asymptote here. And x equal to 1, meaning that we have turning point where the function change from increasing, either increasing to decreasing, decreasing into decreasing, increasing. Okay. So, okay, this one, okay, you can draw the line graph after you complete this table. Okay, step 6, we can see our intervals start from negative infinity to 1. Okay, and then negative 1 to 0, 0 to 1, 1 to infinity. Okay, this one you do it later. Okay, okay, from the number line, okay, write all the intervals. And then from the, okay, we look first row. Okay, from the first interval, okay, take any test point between negative infinity to negative 1. Right now, madam choose negative 2. And then, okay, intervals, test point, and then, okay, we put test point into our first order derivative just now. We want to test either we get positive or negative. Okay, if we put negative 2 into our order, negative 2 square, we get 4. 4 minus 1 is 3. Meaning that 4 minus 1 is 3, positive, right? And then negative 2 square, we get also positive. So positive, meaning that the graph goes to increase. Okay, we're gonna have the increasing pattern of graph because of positive divided by positive. Okay, now we have second intervals, negative 1 to 0. So choose any test point. So right now, madam choose negative 0.5. Okay, 0.5 you put into the first order. So we get here negative 0.5 square minus 1. You get negative infinity. Okay, the value is not necessary. We just take the sign. And then negative 0.5 square. So we get positive. Negative divided by positive. So we get here negative actually. Okay, we get negative. -1. Okay, so means that the graph is goes down. How about the third one, 0 to 1? So our test value might have 0.5. So put into the first order, 0.5 square minus 1, we get here negative. Divide by 0.5 square, positive. 0, negative, divide by positive, so negative. So the graph goes down. Okay, the last interval, 1 to infinity. Choose any number. So madam choose 2. 2 we put into the first order. So we have here 4 square. Okay, 2 square is 4 minus 1. Got 3. So positive. 2 square we got 4. So positive divided by positive. We got here positive. So one just now positive. So positive means that the graph goes up. Increasing. Okay. So from the graph, we know that the graph that gives you the increasing pattern, so means that we have here increasing interval. So our increasing interval start from negative infinity to -1, and then another one we have 1 to infinity. How about the decreasing interval? Okay, this is decreasing interval, -1 to 0, and then 0 to 1. Okay, we now done for part 2.11. Okay, for B, you have to find what is your relative extremum. So relative extremum, you can draw from the graph. Let's say from negative infinity to 1. So our graph goes up, right? So you can write graph from here to here goes up. We stop at -1 because of our interval from negative infinity to negative. So here we have. And then -1 to 0. So our pattern is decreasing. So from -1 to 0, we stop here. This is asymptote. So the graph never touch. Okay, x equal to 0. And then here we have 0 to 1. Graph to goes to infinity. Goes down. So meaning that you have to draw graph decreasing. Start from here to 1, and then interval 1 to infinity. The graph goes up. So stop here and then we goes up. Okay. Now what is your relative maximum? Relative maximum where you have the highest point. So this is our relative maximum when when x equal to -1. Okay, when x equal to -1. What is your relative minimum? When x, we have here, when x equal to 1. Okay, this is relative max, this is relative minimum. This is relative maximum. Okay, so I hope you understand for the topic 2.11 and 2.12. We have here steps, we have 6 steps. Okay, because of this is example, so I show you detail. Okay, if you have maybe you can write your own notes. Okay, step 1, domain, you find the domains. Step 2, you draw the number line, where the number line you use it again for step 5. Okay, and then step 3, you have to differentiate first order, change to quotient form, fraction, where numerator, this is your numerator, this is your denominator. And then step 4, you find the critical values, critical points, when we have set f prime equal to 0, where the numerator equal to 0, f prime x undefined, denominator equal to 0. Okay, once you get the critical values, you find the intervals. Okay, you just now you have number lines, right? So you bring the critical values to the number line. Okay, here we have -1, 0, and 1. Okay, done part for the number line. Okay, you have to draw the table. Okay, first column intervals. Okay, draw all the intervals here. Intervals, and then test point f prime x, where you put test point into the function, into the first order, and then see the pattern, either you get positive or negative. Okay, once you get this one, okay, answer for 2.11 is actually from here. Okay, you can just simply take from the table. But if you want to find the relative maximum or minimum, you have to draw a graph from in the number line. Okay, so relative maximum the highest point, relative minimum the lowest point. Okay, that's all.